All right, good afternoon, good morning, good evening, depending upon where in the world you happen to be today. I see we have a really nice crowd in today's call here, which is quite exciting. I want to welcome everyone to New Approaches to Managing Access to Sensitive Data. I'm going to turn it over to Mandy Chessel here in just a moment, but just a few quick housekeeping notes. First off, everyone should have came in under having their microphones muted. We ask that everyone, unless you're a speaker, keep your microphones muted just to minimize disturbances. If you have any questions during the webinar of the presentation content or any technical issues, please feel free to leverage the chat. We'll be monitoring it in the background and trying to catch that. And if you have questions during the presentation, we'll collect all those questions and then we'll bring those to the presenters at the very end. So with no further ado, Mandy, I'll turn it over to you.
Thank you very much. So for those of you who are familiar with the Egeria, you'll know that our focus is really on gathering metadata from many different tools, bringing it together, and then distributing it to other tools to allow that metadata to be used in sort of to create higher value around data. And so this webinar is really about some experimentation we've been doing with two other open source projects. One is Apache Avro, which is around sort of governed schemas that are embedded within files, so that in your data lake you have the schema and the data kept together. And another open source project called Palisade, which is around it's a scalable policy enforcement engine. So we're going to talk about these two technologies in conjunction with Egeria to show what's possible when you bring these three amazing technologies together. I have two presenters with me, Moya Brannan, who's a contributor and has also been working specifically around Palisades, and Chris Knott, another contributor who is going to take us through the introduction. Over to you, Chris.
Thank you very much, Mandy, and good morning, good afternoon, everybody. So as organizations increasingly recognize the value of data and strive to become data-driven, one of the biggest challenges that data scientists are facing is finding and accessing data. But in parallel, security of data lakes is a rising priority, and that's being driven in part by regulators placing more demands on organizations in their use of sensitive, especially personal information. We're seeing GDPR in the EU, HIPAA in the US, and a plethora of regulations concerning financial services organizations. So organizations are needing to balance the desire and curiosity of the data scientist to explore data, to derive insight and develop analytical models, with the necessity to comply with those policies and regulations. So as Mandy says, in today's ODPi webinar, we're going to show how data in the data lake can be accessed easily using open metadata whilst enforcing information policy. And it's those three technologies that we have brought together to demonstrate this. So we're going to illustrate the integration of those in this webinar from the perspective of a data scientist. And Callie Quartal here is our data scientist. She works for Coco Pharmaceuticals, which is a fictitious company that we use to draw out and show how we can address challenging information governance issues. In this case, Callie is working on several projects where she needs to use personnel data, i.e. employee HR records, and each of those projects has a different purpose. The challenge for Coco Pharmaceuticals is to allow Callie sufficient access to those records and the data items within to do her job without revealing everyone's personal, financial, and performance information to her. So on this slide, you can see on the right-hand side part of Coco Pharmaceuticals' data model for employee data. It is used for data of varying sensitivity, which is scattered across that data model. The examples highlighted in blue ovals are individual salaries, bank account details, work locations, and employees next of kin. There will be valid purposes for accessing each of these, but it's unlikely that combined access to all of them for all of Cocoa Pharmaceuticals employees could ever be merited. One way to record the varying sensitivities of such data is to label or tag the individual items in the data model. And this metadata is held and managed in Egeria. The metadata can be used by people to guide them on how to work with and handle the data, but in our example here, it is purely descriptive. Alone, it is insufficient to control access and demonstrate policy compliance because there is no security layer to prevent greater access to sensitive information than is permitted or reasonable, or to control its use. So we've considered 4 scenarios where Callie will have reason to access the employee records, 2 in her role as a data scientist and 2 as an employee. At the top, we've got the scenario, which is the classic company directory, where Callie will want to look up contact details for other colleagues that she wants to discuss things with. The second one is that she may be interested in seeing the various details of her own employee record. And then for the 2 data science projects that she's working on, the first is a health screening project where the company has decided to offer a health screen to employees that have worked for Cocoa Pharmaceuticals for more than 5 years. And in that case, obviously, she needs to know when the employees started work and be able to contact them with the offer. The second project is a salary analysis project where Callie wants to explore the salaries and the different attributes of the employees with those salaries regarding age and gender and so forth, but obviously can't be allowed to identify who has which salary. So again, some sort of control of data access is required. So to illustrate the 2 data science scenarios, we've got this sort of simple picture before we go into a bit more detail. And you can see that each of those 2, the health screening and the salary analysis, requires different subsets of employee data. In the salary analysis scenario, Callie is able to access data items for individuals such as work location, department, sex, age, and nationality, but not any data that reveals who earns what. However, Callie's other data science project identifies those to whom to offer the health screening and requires access to a different subset of data. In particular, she needs access to people's names, how long they've worked at Cocoa Pharmaceuticals, and their contact details, but Callie needs no further data for this task. So the detailed access for all 4 scenarios is shown in the UML diagrams here, the 4 versions of the UML diagrams, where data items are highlighted to indicate the subset of data required for each purpose. The lighter blue indicates where Callie will need access to all the records, and the darker blue where she will only need access to selected, i.e. specific records. She does not need and should not have access to records that are not highlighted. You can see the variations in the items highlighted, and therefore the access to data items and rows that Callie needs for each scenario. The overlaps need to be managed so that Callie is not able to see too much data in combination. These clear differences determine Callie's ability to access personal, financial, and performance information according to purpose. So I'll now hand back to Mandy, who will describe how we help Callie to do her job whilst implementing the required controls.
Thank you very much. Now, of course, with all security, in the end, it comes down to ethical employees. But people are curious, and you can't forget something, particularly something interesting, at will. So we're trying to allow Callie to only have the data for each task that she needs without being tempted to look at other pieces of juicy information about her fellow employees. So let's think about the traditional case. So when we think about how would you normally provide access to a company directory or allow people to update their personal profile, the real secret is generally when we're working with data, we have that data is sitting inside an application, and the application is like a protective shell around that data that's controlling who can access it for which purpose. And so the application is segregating data and policing its use. So there may be an employee directory application that you can look up, and that only has the data for, you know, the public data about the employees that you can search and browse and share. There may be another application that everybody goes on to update their profile information, and that one, based on your login, will determine which record you can access and update. And maybe there's a modification for managers to see some of those details for the employees that happen to work for them at the time. So these applications are providing quite sophisticated control on who can access which data. Now, when it comes to a data lake, what we're trying to do is to bring together data from many different applications and make it useful for data science. So you can imagine all the data about employees coming from the different applications being brought into the data lake, and then someone saying, well, let's put everything we need to know about an employee into a single data set so that we can, you know, we can do different types of analysis. So you can see in the picture here, the data is coming into a landing area. So at that point in the landing area, the data is separate from each application. And then we're combining it together into this very useful, rich employee data set, which was shown in the UML before. So there's definitely the public data from the from the company directory, but there's also the payroll information and any performance management information as well. So this is the file. So the question would be, how would we then allow Callie to do those two data science projects without just giving her access to the data set? Let's just see. Oh yeah, so this is just talking a little bit about that protective shell, because now we've taken the data, in fact, we've made it worse. We've taken the data out of that protective shell, the application, and we've combined it. So it's a lot more sensitive to any individual access. So the data lake itself has to both protect the knowledge of where the sensitive information is, and also the rules that apply to the use of that data. And so with Egeria, we've been focusing very much on capturing the knowledge of the data and its sensitivity, as well as the definition of the action to take. And that metadata would then be fed into the engines that are automated within the data lake, and provide the access points to data for Callie's data science tools. And the reason that metadata is so important in these cases is that we don't want to lock all the rules into code, making it very slow for the business to commission new projects going forward. In our example, I mentioned earlier on that we're using Apache Avro. Now, Apache Avro is an open source project that provides a standardized schema that sits with the data. So what's super for a data lake environment is that for the files within there, we actually have recorded the shape, the structure of the schema information, of the data within it. And that significantly helps us identify where the sensitive data is located within those files. And as I say, Egeria itself is taking that metadata information, but it's also adding additional information about the fact that this field called salary is sensitive information. And this is the labeling that's required within the sort of the metadata management capability of the data lake. And so if we think about, this is actually going to be difficult to go through. If we think about the data within it, with the, I think I might have to drop out of this just to go through this structure, and then I'll switch back in. So the data, the baseline of this is the data itself, and then we see the structural information that comes from the Avro file, and then above that is additional information that comes from Egeria to provide the business definition and also the labeling of information. And so with that type of information, we can push that into the data lake environment and allow ETL engines to create multiple copies of the employee data set that has the different subsets of information that Callie needs. So she can use her data science tools for one project to look at the employee data for health screening, and then in a completely different workspace, she can access the salary analysis information. And so she's never bringing together the anonymized data with the personally identifiable data. And it just helps her keep those two pieces of work separate within her within her mind. The downside is that, of course, we're creating additional copies of this sensitive information, and the organization needs to have the right mechanisms to make sure that these extra data sets are cleared up once the project is over. Another approach is to actually use views. And we've been doing some experimentation with, can we dynamically generate views over data sets based on the definitions within Egeria. So it's a similar sort of approach in that there are Callie sees two different assets that she can query for each of the different projects. But each of them will allow her to see that correct subset. Again, it's extra work to set that up, but we are now avoiding the copying of data. And in both of these cases, the fundamental problem is that Callie only has one user ID. So when we define our security that is limited entirely by who the user is and what the resource they're accessing, it's very, it's impossible to create that fine-grained differentiation that we need for the data lake and data science environments. What we really need is to be able to bring in a third aspect, which is, what are you trying to do at the time when you issue the query? And for that, to go into a little bit more detail, I'd like to hand over to Moya to talk about the Palisade project.
Okay, hello. Okay, we're all sharing a laptop here, so we're just moving it across the table. So Mandy introduced Palisades very quickly. Sorry, Chris, at the beginning. I'll just reiterate. So Palisade is an open source project that's still in its early stages of development. It provides a set of services for managing and enforcing complex data access policies across many platforms of differing scales. If you see on the slide, we've actually got a link to the GitHub repository for Palisade, where you can find a lot more information. But there are a number of capabilities. I'm just going to dive into Palisade for a little bit that make Palisade quite interesting. Firstly, the architecture, which provides modular data access controllers and independent peripheral services to allow policies to be applied before clients access the data. Secondly, Palisade enables organizations to use centralized services that each deployment of Palisade data access services can share, which means that your data access policies, audit logs, user accounts, details, and so on, don't need to be duplicated on every system. But for us as the Egeria team, what was really interesting about Palisades were some of their key design principles that they'd used when putting Palisade together. So the use of attributes about the query time context of the data access to apply policy. So this is the context of the query that's being made, as the query is being made actually, such that, defining the data that is being requested back. And this becoming sort of a dynamic activity. Secondly, Palisade will consider attributes about the user, and policies can apply a list of rules where a rule is a function on the resource or record, user and context. And we'll look a little bit about that at the demo. So what this means at query time, the access policy is driven by the combination of data assets being requested, so the items being selected. So we've got 4 different we'll be talking about.
Interesting question.
Sorry.
It's my fault.
Okay. The second thing is the individual user detail. And the third, what have we got?
Yeah, just
Oh, sorry. Well,
it's my fault. I just clicked on Siri. There we are. Rather than the
right.
Yeah.
Okay. Quite good. We don't have Siri driving our context at the moment. So quickly to recap that. So at query time, we're looking at the combination of data items that are being requested for that particular query. We're looking at the individual user details and the contextual information that's driving the query. So this could be partly our location, or it could actually be the project. So we're going to talk about project service in a minute, or project management service in Egeria, which is something new we're going to be working on, which will a project. So Callie's working on 2 projects we've already discussed, and each project has a very different purpose, and that can be captured within the metadata of a project and associated with an activity that a data scientist is performing. So if we go, we click on the, okay, great. So working with purpose, we're going to dive into some of the things we've just mentioned, but modern organizations store lots of data sets that are each managed and accessed according to different data access policies. And these policies can be quite complicated, and as we've seen, rigid. Hence, Mandy was talking about creating views and creating duplicated subsets of data to sort of address that, which means access is important, you know, where data scientists are working directly with these data sources. We want to keep it controlled. We don't want to give them too much, because too much information is not very good for our security policies, but we don't want to restrict them. So using a dynamic, flexible access policy is why we were looking at Palisades, so we can look at context and bringing this into the equation. So this is why we pulled together Palisade and Egeria to drive purpose or context of the project or work that the data scientist is performing, which needs to be considered. So in Egeria, effectively when at the point of time of the query being run, we're needing to send through a selection of items and various bits of metadata to drive that particular policy. So the first point is the purpose. And so in Egeria, we're working on a project management open metadata service that captures a purpose that can be associated with the context of a work stream. And a purpose can be given to each project and associated with the assets in that project. So then at the time of the query, Palisade is able to assess the user accessing the record and the information that it has about the particular user, the context of the record, and very importantly, the contextual information that's being given at query time by the system or the user. So deriving purpose in that particular example is one way of doing it. There are other ways of doing it, but pulling the purpose through from the metadata to then be used with the policies that they have within Palisade is quite a powerful thing. So we're going to walk through the architecture of Palisade. And there are 2 things that we want to highlight, because within Palisade, as we're using the metadata, it's feasible for very large data sets to speed up the retrieval of the actual data, which was of interest to us again, because normally we're looking at larger quantities of data. And the second interesting thing was the Palisade's ability to add fine-grained policies, not just normal policies, but actually make these enhanced. So I'm going to walk through the architecture and what is going on behind the scenes here. And then after that, we're going to sort of dive straight into a demo of what's actually taking place. So first of all, the data consumers, who we can see up here by the Palisade client, uses a client that provides an identifier to the data, their credentials, and any required contextual information. And this can be coming from the metadata within Egeria. The user is authenticated with the user service, which we have over here, hiding away. Everything's controlled through the Palisade service, through the user service, and the user's attributes are provided back to the Palisade service. Palisade service now gets the Egeria resource service to provide full mapping of all the required data resources, or other assets that are available from the data lake, along with how to find and connect those resources. At this point, Egeria checks that the user is allowed to access the assets based on who they are and where they are. So the policy server then will firstly apply any coarse grain rules using the user's attributes, query time contextual information, and the resource metadata. Secondly, the policy server retrieves the fine-grained record level rules, which require access to the individual data records to be applied. Next, the Palisade server caches the contextual information, user attributes, and the mapping of resources detailed on each resource's fine-grained rules. These details are all cached under a token, which can be used to retrieve the data later by the data service. And when we're in the demo, we'll have a look at the data service because we can actually see that being invoked as we go through that. The Palisades service returns a token along with the mapping of the resources to the data service, connection details, and the user is allowed to access. The request, outcome, and summary of the data provided are logged via the audit service, so we keep track of everything going on. For each resource, a request is made to the data service, passing through the token and resource details. The data service uses a token to request from the Palisade service all the information required to enforce the fine-grained rules to the data. And then finally, the data service connects to the data and applies the rules which transform and filter the data before it's streamed back to the client. And this will make far more sense when we start looking at the demo. It's quite a complicated process, which we've sort of condensed down here. So to switch to the demo, how do I make it? Sorry.
That's all right, no problem. So let's encourage it to come back. Right, let's come out to the show and pick up QuickTime. So there we are.
Great.
Everything you need.
Thank you. So this demo is hot off the press. We've put the demo together in a Jupyter notebook. And if you go to the Egeria website, pretty much all the demos we have are run in Jupyter notebooks. So we can sort of put lots of description about what we're doing when someone then goes and runs our demos. So if you go and actually look at our blogs, you'll find a way that you can get to our demos. What we have here, we've already mentioned Cocoa Pharmaceuticals. And at Cocoa Pharmaceuticals, they've got a number of open metadata and governance server platforms. The one we're looking at today is the Data Lake platform, which is where we're going to be doing our work and where Callie is going to be running her queries. So again, I said this is hot off the press, so I'll set this off. I'm going to pause it a couple of times so I can point out various things. What's happening first of all is we're setting up our connection with the Egeria open metadata governance server platforms, and we're also identifying the characters who are involved in adding, defining, using, retrieving assets. And you can see down here as this is running through, we've got Callie being defined, and Callie is our data scientist. We've also got Peter Profile, who's an information analyst, and he's going to be creating the asset in a moment. We have Irene Overview, who's our CDO, or deputy CDO, and she'll be setting up zones for that particular asset. And actually, I'm just going to pause this a second so I can finish off mentioning the other players. We've also got a character called Gary Geek, who looks after our IT infrastructure. And what Gary's going to be doing is he's going to be, first of all going to be adding our asset. We'll just go back a tiny little bit. Oops, sorry. There we go. Gary Geek here, yeah, sorry, he's running up the servers. And then as we go through, we've now got here being created is the asset. So we're going to add an asset first of all. So let me just pause this here. And what we can see up here in the body section here, we can see the details of the asset. We can see the display name, the Cocoa Pharmaceuticals employee record, which is our Avro file. We've got a description of it, which has got our detailed employee records in, and we have got our path to where this exists. So we've got a couple of directories, and then we've actually got our file. I mentioned earlier as we were walking through the description of what's happening in Avro, the data service. So we've got our Java class detail file here, and we've also got our link as to where we get to that. And we go through and we can see the asset being added, where we can see GUIDs being assigned to identify the various parts of the asset as well. So let me just start this so we can move down. And we can actually see here the assignment, where my mouse is at the moment, of Faith Broker, who actually owns this particular asset. So, yeah, we are moving down. And again, down here in this section, we can see zones that are being defined for the asset. What's quite interesting here, we have, we can see at the very bottom, we can have the zones where this asset is being added. So it's being added to the data lake zone, human resources zone, and where the folders are also being added as well. Quite often with Egeria, we'll have a quarantine zone. So when assets are put in, they'll go into the quarantine zone, and then they'll be added by asset owners to various other zones later. So if we carry on running this, we should go down in one moment. Here we go. So the next thing that we're actually doing here is we're about to search for the assets and pull back the asset information that we've actually just loaded up into Egeria. So if I run that, the asset information will come back. And we can actually see here, we can see our GET API, where we're searching for assets that have got HR in the string. So the asset has come back, and it's showing us the information that was captured about that asset. If we have a look in here, we can see, going past at the moment, details that this was an Apache Avro file. We've got the details coming up here also about the file name, its location, and we can see it says 2 assets have been found. And these 2 assets, one relates to the folder, the other asset actual to the physical Avro file itself. What we get onto next is, in my opinion, the exciting bit, because we're actually going to look at the individual queries and what comes back. So here, see if I can move the little time bar across. I can. We can see each of the 4 different queries that we talked about earlier on in the presentation. So we've got profile access, which is the access about Callie herself and when she's pulling this back. We've also got the company directory query or request for data, which is providing information about Callie's colleagues and their contact details. Then we have the 2 bits of research that Callie's working on, the health screening for the employees where they've had 5 years of service at that company and they're entitled to like a free health screening, and then the salary analysis. So each one of those queries requires conflicting sets of data coming from the same file. So this is where we're going to use context, which is defined by the purpose, which is either profile access, company directory access, or health screen or salary analysis, to bring back different sets of information. So we'll set this back off again, and we'll click on one of them. And first one we're going to do is the profile access, to show all the information that is in the file. As Callie, as she's looking at her own information, can see all the details about herself. So this has come up, and we can see Kelly's hire date, for example, down here. We can see her mobile phone number. Also in here, we have her home phone number, and we'll have information about her emergency contacts. So absolutely all the information that pertains to Callie is in this, because we're basing this on contextual information. There was multiple fields that we were considering when we were looking at this. So, you know, who is the user, what was the purpose, and, you know, the data that they're actually requesting back. So for this particular one, we had all the details back. Now we're running the second query, which is company directory. And of course, this is pertaining to information about colleagues of Callie. I'll just pause that one moment. And so here, we only need to know the individual's ID, their company contact details, and possibly what their role is at the organization. So you'll notice lots of information has come back as being redacted. And we can just see, for example, for Gary Geek, we can see his name here, and we can actually see his work phone number. And the record's much smaller. We can't see his gender, we can't see his address. And actually, if you look at the salary amount and salary bonus, they've both been set to -1 and have been for everybody else in this particular data set. So this is dynamically changed based on the purpose of the query, the user making the query, and other contextual information around the query. So let's set this off again. And we'll have the third one coming up. There's quite a few people here at Cocoa Pharmaceuticals that we're looking at. And then the next query we're going to look at is the health screening. So here, for this particular one, we're very interested in working out people's start date at the organization. And we'll need to know their contact details, but things like salary information are completely irrelevant. So that information needs to be redacted. And again, here we can sort of see the relevant information. We can see a hire date for this particular person. We can see, actually, this one's Callie Quartile, but we've actually got Tessa Tube below. We've got her hire date, and we've actually got her home number. So this can be created as a set of information for the HR team. Again, if we go on now to the final one, where we're doing salary analysis, and the purpose for this particular query is salary analysis. This time, all the contact details or identifying factors for the individual are removed. And actually, what we've done here, one thing that's quite interesting, I'll pause this, is where we have date of birth, because date of birth and the age of the person could potentially be very interesting for this query. What we've actually done, based on the purpose and the context, we've put asterisks here for the actual day, because date of birth could be something that could identify that person. So it's possible to actually sort of start going through, altering or redacting parts of the data and masking the information. But here we've actually got lots of information that's going to be very useful for doing a salary analysis, such as, yeah, hang on a second, I'm just looking down here. We'll just start this again, sorry. So we've got lots of information about the hire date. Should have had, sorry, I'll just pause it. Oh, hang on, here we go, it's coming up again. So I'll pause that there. Actually, we were looking at the previous one. So have we got that? No, we've just gone on past it now. So we'll just pause that there. But for the last one, we had the information that was relevant to doing the salary analysis query. So each set of data is appropriate for that purpose, for the user, and the context surrounding the query. So at that point, I'm going to hand back over to Mandy.
Thank you very much. And we'll switch back to the PowerPoint, and now the demo's over, and we're into the summary section. So we've covered an awful lot of ground, but I hope what you're taking away from this is that in a data lake environment, we are bringing together lots of data, different data from different applications. We're taking that data out of the protective surrounding shell that those applications provide, and we're then combining the data together. So we're creating data sets that have a combination of public, private, sensitive, financial, all the words that basically bring the need for complex rule-based security into play. So data lakes, we've known for many years, have had to have this more rule-based approach, but typically we've based that security analysis on who is the person and what is the resource. And we've been using classifications for around the resource. What we've been showing you today is that actually even that's not enough. And we need to start bringing in the context of the specific piece of work that someone's doing, so that they, on each project, they only see the data they need, rather than being given an aggregated total of all the data they will need for all of their projects, which is what tends to happen if you just use who the person is and what the resource is. So, so by making this a programmatic service, but the ability to add context, by making that a programmatic service, we reduce the need to copy data, create special subsets, create special views over the data, and everything can be handled through metadata and policy definitions that can be controlled by the security team, the data owners, and the project oversight teams, without without requiring a coding or administrative effort to get these to get the IT to reflect the requirements of the organization. So we think that this technology is obviously early days. We're performing a number of proof of concepts as we work with it, but we think it's incredibly promising, which is one of the reasons why we decided to share our initial findings in this webinar. So I hope you've enjoyed our presentation. And as John said, if there are any questions, we'd be very happy to answer them.
Thank you, Mandy. I have a few questions that have sort of come through various channels, and please continue to use the chat to share any questions you might have. You can see the chat in the presentation console and just share those questions, and we can relay those to the presenters. A first question, and this one's for Mike. How would you say is by using open source an advantage for handling sensitive data?
Ooh. I think what's interesting is that in an open source community, you're bringing together people who are skilled in different aspects of this problem. This problem is very complex. And so I think the open source communities allow that varying expertise to be brought together to create advanced solutions. So to me, it's the collaboration, the community, and the transparency of the work that we do that's so critical.
I think I absolutely agree with that, because you know, Palisade and Egeria couldn't be more different as capabilities, but to drive that context, you know, is something that's coming from metadata. And also, one of the things we didn't talk about was setting up all the different contextual information and the ability to simplify the whole process of identifying access policies for different data items, you know, data assets, by using metadata to define them. You know, Egeria will bring a wealth of information about all those assets that need to be classified, which can be used in Palisade. So I think it's the two communities which do very different things, and with it being open source, it's very easy to sort of come together and work together to sort of produce these capabilities.
The one thing I would add is that I think open source is really about community, and community allows different parties with different regulatory and information governance requirements to come together and collaborate on how best to tackle some of these difficult challenges.
Great, great. Thank you for that. We had another question come in here. What do you think is the biggest barrier to implementing ODPi Egeria along with a comprehensive data management system in companies?
I think often when it comes to data, there's a big divide between the knowledge in the IT team and the knowledge in the business. The business tends to see data very much through the lens of the application. They see it in a consistent, sort of well-managed format. But actually, when you look at the data and how it's implemented, it's a very complex landscape. So to me, the biggest barrier for many organizations is that communication and that understanding that there needs to be that common shared capability that allows multiple tools to take data from multiple places and bring it together and operate it. It's almost like there's a problem there that no one even knows exists, and it's not until you've been taken through the potential that Egeria offers that you can start to see why you need it.
Could also be a bit of a mindset thing, because so many people, well, that is as well, but so many people assume all these things don't operate together. You know, interoperability is a bit of a panacea. So, you know, having a brand new standard that enables all these data repositories and, you know, processors to be able to communicate together is something that, you know, it is new. Egeria is still a young open source initiative as well. I think not many people have heard of this yet. So hopefully once people become aware of this, you know, they'll know that it is feasible to gain, you know, a complete view of the entire data landscape, to have everything sort of being able to interoperate together and be managed and governed in a coherent way across an entire enterprise, even if it's sort of siloed by, you know, country divisions and things like this.
Yeah, and I would say that Egeria is starting to become more interesting. I've seen a number of analyst reports that are starting to talk about Egeria and even be very poignant towards vendors that aren't looking at Egeria at this point, supporting their products. So I think the communication is definitely getting out there, and with the great attendance of this webinar here as well, this is certainly a challenge a lot of people are feeling. And so materials like this are certainly a step in the right direction. Still, anybody else who has questions, you'll throw them in the chat. I have one other one here. This will be the last one unless we have any more that come through the chat. What would be a good first step if you sat through this webinar and you've got a good assessment of the challenges around data management, and you're looking at ODPi Egeria? What would be a good first step for assessing ODPi Egeria for your organization, or if you're a product company, for potentially supporting in your product?
So I think that there are a number of steps. So if you look at the Egeria website, then we've got a lot of best practices around how you build a data strategy, how you start to think about governance, and that links down onto the Egeria technology. So depending on the area of focus you have, maybe one of those scenarios will help to guide you to the first, the parts of Egeria that you need. If you're more a technical person, or you're interested in how the technology works, you can download and follow the instructions to set up and run Egeria. And if you're a vendor, the other thing to look at is our conformance suite that helps guide you through the process of integrating your technology into our metadata environment. And again, because it's quite a complex environment, as Moya said, we have built a number of hands-on labs. So there's a Kubernetes and a Docker deployment. That means you can very quickly set up a number of platforms and servers that are connected together. Then there are hands-on labs that take different ones of our different personas and focus on the tasks that they care about. So there's one about how to administer the Egeria environment. There's one about how asset owners work together. There's another one how you bring common models into this type of ecosystem. These are backed up by coding examples. So there are different types of connectors that you need, and we've got samples with that. And again, these all link back to the best practices that we call guidance on governance. So we've tried to create lots of different entry points for people based on their role, their level of expertise, and their the type of issue that they're trying to handle.
Yeah, the community's done a great job, and definitely this is an area where any of you who are on this call can feel free to contribute to these efforts. Matter of fact, I saw an issue raised by the community just a few moments ago in the background. So the community continues to work even through webinars. So it's fantastic to hear. We had 2 more questions come in. One here. Does Palisades and or Egeria provide a UI that allows these contexts and rules to be defined?
Not yet is the answer. So we definitely we are thinking about how that should be done, and I suspect that we will do a number of sort of proof of concepts around this, because this is really how the business needs to operate. So it's around what type of roles do we need in the business that make decisions on what is appropriate data for this type of project. So you know, there are discussions in the industry about data science or AI ethics boards. How would that fit in? Are they the right people to be defining what's appropriate for each context? So there's a sort of organization and role design around this, as well as thinking about what would the UI be. So it's an area we're particularly interested in, and likely to be a focus going forward.
Definitely, and also an area that if you have expertise or feedback or ideas, the community would, a great opportunity to get involved in the community as well.
Yeah, absolutely. Everyone's welcome.
Yes, more hands makes the work light for sure. One last question, and then maybe we'll wrap it up. And if there's any more questions, you know, feel free to also get to us on social, contact us on the mailing list, and we can certainly wrap that up. Can you talk about how Egeria, in the context of actual data source, along with metadata? Like, so for example, how can you automatically author metadata into Egeria?
Super. Okay, so we do have simple APIs where you can say create asset, and that's creating a description of a data set, for example. We also have what we call governance servers that are integrating directly with particular data platforms. So maybe it's Cassandra. Cassandra itself generates an event every time someone adds a new schema to the Cassandra environment. And so we capture that and automatically catalog it. And in both of those cases, generally what's easy for us to do is to capture what we call technical metadata. So the schema information, the location, everything that's provided through the standard client. We then have something called metadata discovery. We have a discovery server that runs pluggable discovery services that can look at the content and then start sort of characterizing that data. Generally, we need to bring a steward into that process to tie that together. And then there are other people who are using the asset itself, or looking at the descriptions and searching for things that can add their own labels and comments and collaborate around that. So what we're looking to do is, through our ability to integrate with many different types of tools, is to allow people across the organization and across the data landscape to contribute their knowledge that is then brought together into an integrated knowledge source through the Egeria integrations.
Fantastic, fantastic. Well, thank you so much for all the presenters for today. If you do have any further questions, again, feel free to reach out via the email lists, the Slack channels, or on social, and we can definitely help get you the right connections. This webinar we will make available on our YouTube channel. We'll provide an update on our blog when that's available. And we just want to thank everyone for attending the webinar today. Hopefully you all got a good amount of knowledge and insight on the Egeria project and some of the other open source efforts around it. And we hope you have a great rest of your day, evening or morning, depending upon where the world you happen to be.
Yeah, thank you, everybody.
Thank you.
Cheers. Bye now.
Bye.